This is example 4 from the radiation notes, and you should try this example once you've read pages 8 and 9 of your notes. Some hospital staff wear film badges to monitor their exposure to radiation. The film is contained inside a plastic holder with windows of different materials shown in the diagram. Light cannot reach the film. So there's a thin sheet of paper that goes over the top of the film so that it doesn't blacken just because of the daylight. What you've got to do is shade in the windows that would turn cloudy when the monitor is exposed to beta radiation. Now, to help with this, there's a nice diagram from the BBC Bitesize website here which shows how radiation, the three different kinds of radiation that we use at National 5, alpha, beta and gamma, can be absorbed by a range of different materials such as aluminium or lead. Now we can see that alpha radiation is the easiest to absorb. It's blocked by a thin sheet of paper. But beta radiation, which is what we're looking at in this example, will actually go straight through paper and requires about 3 millimeters of aluminium in order to absorb it. So then we can apply that information to solve the example. Shade in the windows that would turn cloudy when the monitor is exposed to beta radiation. So the first thing to notice perhaps is that with the aluminium panel, with a sheet of aluminium over the top of the photographic film there, then none of the beta radiation is going to get through. And so that area will not be blackened by the beta radiation. The same is true for the lead. Even though it's a thinner piece of lead, lead is even more efficient at absorbing beta radiation than the aluminium is. So those two sections will both be left white. But the open area, which doesn't have anything over it other than a very thin sheet of paper, well, the beta is going to go straight through that, and the beta radiation will blacken that part of the film badge. That only leaves us to think about this area with a thin sheet of plastic. Now, a thin sheet of plastic will block some of the beta radiation, depending on how thick it is. So there will be a little bit of beta radiation, or even a reasonable amount of beta radiation that's going to get through here, but it won't be quite as much as was getting through the open window. So we will see some blackening and some darkening of this area here, so that needs to be partially shaded in, and that's you.